So it is today we're doing something a little bit different. We're doing some geometry proofs, or not proofs, but some geometry exercises. So we start out doing logic. Then we have 2 more sections that are over geometry that we're going to do today. And then next Tuesday, I believe we're doing a review, and then we're taking a test next Thursday. So coming up pretty quick. And so I don't know if I said it already, but I have part of your first assignment graded. There's a few more to grade, but I'm partway through that first one. So I intend to get grades turned around pretty quick here. That's the next thing on my list. I got to grade your stuff, and I got to get you a quiz by next week. And are there any questions over anything so far that we've done?
So, yes, but it's probably coming. It's been a really long time since I've had to like convert fractions into decimals and stuff. Are we going to be going over that?
So,
or is that just kind of like?
I mean, I can go over that, but probably not within like class.
Okay. I mean, like, I'm figuring it out. It's coming back to me, but
yeah, you can do it.
It's not
like
something I use in my daily life, so.
But also, like, I don't know, and I can not really sure what it says in the syllabus or what I can require of you with technology, but like it's like one of those things. If you spend a little bit of money, it might save you a lot of headache or heartache. I don't know.
Don't feel bad, Lisa.
But I know, like, I know.
I mean, I was like, oh shit! Like, I have to get this square root, this square into a square root. Now it took.
Yeah, I mean, I'm looking at. Okay, so I'm just gonna wait for him to do the geometry. But yes, I'm going through the same thing.
Okay, good.
So I'm just gonna sit and wait. So don't feel bad, because yeah, I'm right there with you.
All right, awesome. I'm glad I'm not the only one.
Okay, so if I have something like 1698s or something, so a lot of them, I don't know if you can see my calculator, but a lot of them, like in the like TI 84s, it's just like math frac. So if you have a decimal, a lot of times it's easy if you have technologies just to kind of convert from decimal to fraction.
Okay.
And it depends what we're doing. Sometimes I'll want a fraction over a decimal. But for most of the stuff, these are application problems. I think if you give a decimal, that's pretty good.
Yeah, and then just for the test, should we have these formulas like memorized?
Which formulas? I think like the area of like a rectangle and like area of a like triangle might be fair game.
Okay.
Like the simpler stuff probably is fair game, but like I don't expect you to know like volume of a sphere or surface area of a sphere or any of that crazy stuff like that.
Okay, so like when we're doing problems like that, those formulas will be provided. Well, certain formulas will be provided in the test.
I think area is a fair game.
Okay.
Because it's pretty straightforward with how you do your areas. Surface areas. I think I would try to like probably give you like the formula if I was doing surface areas or volumes. If I'm being honest.
Okay. Thank you.
This button and this button. These are your switching. Did I do that right? Yeah. This button and this button.
Okay. Thanks, Chris.
So I don't, like I had to go to YouTube to look at the instructions on how to operate my this thing is awesome to learn how to operate this. But if you do the number, okay, so there's a way to do the fractions too. But once you do a number and then you click the second and then you go here. But now the fractions are right here on this button right here.
It's like really hard to read those buttons. But
yeah.
I think so I want to talk a little bit about I'm probably preaching to the choir is what's probably going to end up happening. But like I'm getting like a lot of emails about stuff that I've kind of answered or stuff that's in the syllabus, and I don't really know what to say, but like there's 30 something students in this class, and if I spend a minute with each of you, that's like 30 minutes already. And it takes like a minute to respond to emails, so I can't be answering like stuff that we've already done in class. I can't really like keep responding to stuff about like the syllabus and stuff that is in the syllabus or the schedule, and like I'm trying not to sound like a jerk, but like the whole schedule's in the syllabus. If you miss a day, like I can't be the one like telling you everything that you missed. You're gonna have to find someone else to ask or figure it out on your own somehow. Like the videos are up, the schedule's up. There shouldn't be any question over like what happened in class for the most part. It's all laid out. There were a few people with like legitimate things that were emailing me, so I don't mind if you have something legitimate, but like if it's like what did I miss or like something along those lines, or can I submit this late? I've kind of already gone over those sorts of things. Some people had excuses for why they were late. Those are good. I'm not complaining about like showing me your excuse. That's what you're thinking. Like you're doing what you're supposed to do. But there's some people just like they seem lost, and it's like I don't know what to tell you. You got to come to class. You got to pay attention. I can't be giving you a class through email. That's not how that works. Like I don't get paid nearly enough to sit there on my
That's funny. Class through email. That's funny. Anyway, excuse me. I'm gonna go get some coffee. I'll be right back.
Yeah, I got my yerba made right before class. Okay, so let me fix this a little bit. I feel like it's a little leany, maybe. That's probably even worse now. Okay, so for these 45, I'm starting on 10A. So if we want to do this 45, we want to do area and perimeters is what they ask. I think perimeters. If I'm walking the perimeter of this, what do I have to add?
I think that's 46.
Is it?
Yeah.
45 is the one above it, huh?
Yeah. Sorry.
Oh, that's weird. No, good call.
Yeah.
They are pretty similar, but what do I have to add here? What is my perimeter going to be? So this one's probably even easier. You could probably just jump right to it. Maybe. What was it?
5 + 5 + 8.
Yeah, it's it. We're just walking around the outside. 5 + 5 + 8 will give me 18. Oh, okay. What about the area? Do you remember how the area of a triangle looks?
Base times height divided by 2.
Yeah. Or 1/2 base height, base times height divided by 2. Either way. 1/2. What's my base here? What's my height?
Base is 8, and height is 3.
3, yep. Yeah, they're cutting in and out a little bit with the vocals. I don't know. But I think I heard it. It is 1/2. My base is this 8 right here. My height is 3. What is this? If we have 8, that's going to be 4. We can do 4 times 3. Should be 12. And they don't tell us anything on here, huh? Let's say this is something. If I'm doing perimeter, what would be my units on my perimeter?
So how did you do the half?
The half, I want 1/2 of 8.
1/2 of 8.
That
Okay.
would be 4
That's
times 3. Yep.
1/2 of 8 times 3.
Yep.
Okay, so can I ask a question? Does that okay, so that concludes measuring just those two for the whole area, because you break off the bottom base. Is that what that is? You make the 8 4.
Yeah, so there's a few different ways you can do it, but yeah, that's one of the ways. And so if these are measured in inches, then what would my perimeter be measured in?
Inches squared?
Still inches.
Yeah, this is still inches. The perimeter would be inches, and I think this is probably where you're going with it. What would my area be? This one would be
Squared.
the square inches, yeah.
Yeah, it'll be square inches.
Perimeter, yeah, so don't get confused, and this is good. I'm glad someone said it, because now we can talk about it. Like, perimeter, it is a one-dimensional measure of distance around a 2D object. So it's like you're going back, and you're doing a one-dimensional around a two-dimensional, right? We can always go lower dimensions when we measure stuff. We can do perimeter around a two-dimensional object. We can do like surface area, right, on a 3D object. Okay, so 45, we did 45. 47 is this window space.
Oh God, this thing here.
So this asks how much trim, and then it asks how much glass. So they ask how much trim, and I believe they're just talking about this outside blue trim. They're not talking about this inside gray stuff. So if I just want that outside, what do I have to do?
Find the circumference of a circle and then add it to 16.
Yes. And so going over that a little bit, you're trying to find the circumference of this circle. So this circle is a half a circle. This circle is a half a circle. So there's a few ways to think about it, but we have a whole circle in here somehow, right? So we want the circumference of this circle. So circumference would be, there's a few different ways. You can do pi diameter or what, 2 pi r?
So
what?
Okay, so do I do it by 2? Is it 6 times 2?
So the 6 is the diameter if you're going with the 6.
Here. Yeah. Okay, so but he did this side. So is it the same on this side, right? Or
Yeah,
is it
so
all
this-
just one side?
So this is half, and this is half. If we add 2 halves, we get a whole.
Whole, right? So would it be 12?
So we want a whole perimeter. So this is the diameter. So it's a diameter of 6, or you could do the radius is going to be what?
3.
Yeah. And so either you're doing 2 pi r, or you're doing just pi d. Either way you do that, you should get 6 pi, right? And so that's accounting for the circle. Part and its part. It accounts for the whole thing.
So you did so P is pi, right?
2 pi r. P is the perimeter. So we're doing 6 pi. We're adding 8 and 8 to get that long straightaway part.
All right, so the 6 feet, I understand that. Okay, so the 6 feet. So is that times 2? Or is that
This is
6 plus 8?
6 pi.
Yeah, so the pi, is that times 2 or what?
This is 6 pi plus 8 plus 8.
Okay. Doesn't that change the number with 6 pi?
Okay, so 6 pi you have to figure out. You can do this as 6 pi plus 16 if you want. But that 6 pi, you're probably going to need a calculator or something of some sort. You're going to have to do 6 times 3.14, or you can just type the value in your
That's what I
calculator.
was thinking. Okay. 6 times, okay, hold on, 6 times 3.14. Now we understand it. Okay, so that's, okay.
So this should give you somewhere around 34.85.
Plus 8. And then plus 8. Okay, I got it.
Okay. So if we have this, and what is the dimensions on this, or not dimensions, the units, I guess is what I should say, right?
Feet.
This is going to be flopping around this thing.
So it's 3 point. Oh my calculator.
Okay. So this was a perimeter 385 feet. This is not what they asked us. So what is this? How much metal trim is needed for the perimeter? So this maybe you want to say 34.85. If they ask us a question in English, we should probably like give them some English back. Okay. Okay, so the next part is how much glass are you going to need for this thing? And I hope you look at this.
So I rounded off. It's 3484, but by being close to 5, I guess it's 3485. Is that correct? Is that what you have? Is that what that is? The 3485?
34.85, yeah, that's what that was.
Okay, so you rounded off.
So for this one, we're looking at the area of this thing. So if we want to do the area, I don't know, there's a few different ways to do it, but the way I would think about it is that we have two sort of things that we're doing an area of. So I guess we could, this is just one of them. So if we look at this, we're going to have to take the area of a circle, right? So I'm hoping you're like, in your brain, you're just like piecing this thing together as one circle. And then there's this other object. I guess it kind of draws itself now. Another object that looks like a rectangle of some sorts, right? And what are the dimensions on this thing? I think this one's the easier one, right?
8 by 6.
Yeah, it's a 6 by 8, 8 by 6. So that one should be the easier sort of thing to do, hopefully.
Oh, so A2 represented the inside, and A1 represented the two
circle halves.
The two circles on the outside.
Yeah,
Okay.
So if they give you, they're giving you a whole circle here. If they didn't give us a whole circle, we'd have to half everything, right? Yeah. But here they're giving us a whole circle. So we want to know, how do I find the area of this circle? So I'm going to take pi, and I'm going to take what?
Radius?
Yeah, what was my radius here?
3.
3 was my radius. So I'm taking pi r squared to find the area of the circle. What's the area of that second rectangle? A 6 by 8 rectangle is going to give me what?
48.
That's going to give me
48. Yep.
And so if I want the area of the whole thing, what am I doing with these? What's the operation?
So is it 3485? It is okay. So is it 3485, 34.85 minus 48, or is it times?
No. So that's the perimeter. We're working with just area now.
Oh, okay.
You add 48 and pi r squared.
Yeah, exactly. So this one I'm going to do a little crunching. 3 squared is going to give me 9. So I'm going to have to add 9 pi and 48. And so at this point, I'm going to have to grab my calculator because I don't know what the heck 9 pi plus 48 is. I'm getting something like 76.27. Somewhere around there.
So can I ask a question on the A1? Is that 3? Is that 3.14 times 3?
Times 3 squared. Yep. Pi r squared is what we're doing.
Okay.
And so we're getting 76.27, and this was measured in feet. And so my area is going to be in what?
Squared.
Should be square, right? Area is a 2-dimensional measurement. We're talking about how many little square feet we can put in there. It always reminds me of Witches, I think is what it was. It's like an old Disney movie where the witches had square feet. Okay. So was that 45, 47? Oh, man.
So I got
Yeah.
7626. So can you go back to the is it okay? Are you moving ahead? Okay. No
Yeah, I mean, you can go back and watch the video. So it should be up.
yeah. All right.
Okay, so 49, they want us to build stairs, and they have this little diagram of these. This is my horribly drawn diagram that I had to bring up from the notes. But this is my diagram. I don't think this one's too difficult if you understood the previous one. And so they have this region under the stairs that they want to cover with a right triangle, basically. They're going to put this side up against the wall, and this is against the floor. So you're making a right triangle out of this thing. And they want to know what is the area of the region to be covered. So what's the area that I'm using? What's the formula that I'm using for this thing?
Base times height divided by 2.
There's a few ways you can do this. Some ways might be a little quicker. So base times height divided by 2. That's what I'm doing. Not too many numbers to give you, so I don't know what else you're going to do besides 12 times 11 divided by 2. A little bit of math. Maybe you can do this simpler. You can do some cross simplifying. But I think you should get 66, right? And we're talking about area, so this is going to be 66. And what's my units on there?
Feet squared.
Yeah, there you go. Feet squared. All right, 49. I want to do 51 next. Oh man, I stapled my paper together. Now I gotta do this. Okay, 51 says we're in a parking lot. It's shaped like a parallelogram, and they want to know how much asphalt in square yards is needed. This is the picture. And so if they're asking how much asphalt, what are they asking? They're asking for square yards. And it says that in the problem. So what are they asking for? Is that perimeter or area, I guess is the question.
Area.
Yeah, it's got to be area because they're asking for square yards. How do we find the area of a parallelogram?
Base times height.
Yep, it's like two triangles, like half of our parallelogram. So we got base times height. What you're gonna do? I guess I'll leave you to it. There's two numbers there. I guess you could try to do 180 by 180 if you were confused. I don't know what else you're gonna do. The height is based on like something that's what? Perpendicular to that, and it runs from one base to the other. So you might notice this 150 is going to run from this street to this street, right? And it's perpendicular. So that's what's telling us that's the height. So if we do 180 times 150, that's giving me the number 27. 1, 2, 3. So it should be what? 27,000 square yards. And I I'm going to go ahead and I guess I'll say it. In this section, we're doing a lot of geometry, and we haven't gotten to like the unit analysis section. So there's a lot of sort of like conversions that we're doing that we don't have like kind of the tried and true method or way of doing the conversions yet. So if that seems overwhelming, there will be a whole section just on unit analysis and unit conversions. One way we can kind of look at our units is that is yards and that is yards. If we multiply yards by yards, we're going to get yards squared. So your units should match up with whatever the heck your units were here, right? To some degree. Probably to every degree. If you do it correctly. Okay. Are there questions about this thing?
Can I ask a question on the yard, the 2 yards? If it said yard and meter, what would it be?
That would be something else that we'd probably have to convert.
Oh, okay.
The same thing. There's not something. There'd be yard meter. There's no yard meters. I don't know. There are foot acres or something like that, which is kind of weird. And that's a volume measurement, but they use that for weird stuff. I don't know. It's very specific usage. Where are we at? 51. We did 51. We're doing 59 now. Water reservoir. There's a water reservoir for a city shaped like a rectangular prism. It's 250 meters long, 60 meters wide, 12 meters deep. At the end of the day, the reservoir is 70% full. How much water must be added overnight to fill the reservoir? Okay, so there are a few ways you could probably go about solving this. And we haven't even gotten to the section that's about percentages. So if that's like what's tripping you up, don't even fret. Our base here, that's really horrible. And this is going up like that. Our base looks like, what are they giving me? 250 meters long. This is not to scale whatsoever. So 250 by 60 by 12 meters deep. So if we're talking about how much water this thing can hold, what do we want to know about this?
It's volume.
Get volume. We multiply
Base
those
times.
Yeah, base times height times, what is it? Depth, I think. There's a few different words they use. Length times width times height. We're going to multiply the three numbers. 12 by 250 by 60. I feel like I keep cutting you off when I shouldn't do that. It's not intentional.
Okay.
I don't like talking. I don't like talking. I like to hear y'all's voices. 180. Preferably your voices discussing the material and getting it correctly. That's the best. But, and another thing, this is like a meters times a meter times a meter. So if I'm thinking about my units, someone whispered it. Cube. There we go. So this is the volume. This is the volume of the reservoir when it's what, 100% full? We know at the end of the day, it is 70% full. So how much water do you need to add to that to fill the reservoir? Okay, so not even looking at this number. If it's 70% full, how much of that are we going to have to add to it to get a full reservoir? A full reservoir meaning 100%.
30%?
Yeah, so we're going to have to add 30%. We're going to have to add 30% of whatever the heck this is. And so we haven't gone over the percentage thing yet, but if we want to do 30% of that number, we multiply 30% as a decimal times 1,800, or 180,000, sorry. I will like almost always say those numbers wrong. I will say 100 when I mean 1,000, so This is what, 5,400, and we're doing what, meters?
All right. So I assume that the length, since we're talking volume, the length is the actual long. I mean, the width is the long, correct? And we're talking volume, it says width here 250, but it says 250 meters long. So I assume when we're talking volume, we're talking, when we're talking width and volume, we're talking long.
This is length, this is width, and this would be the height, would be the deep.
Length. This is length. Okay. So long is the width? That's
Long would be length.
The length, okay, that's what I
Wide
thought.
would be width, and deep would be depth or height.
Height, okay.
Okay, so for 63. This is with the scaling factor. And so I talked briefly about this, but it depends what dimension you are in when you're doing your measurements. One line that is like what, 1 inch? I'm tripling in a single dimension. Dimensions would be, so one dimension would be times 3. 2 dimensions would be times 3 squared, or you have to do times 9, right? So you have to account for whatever dimension you're in. 3 dimension would be what, 3 to the third, or times 27. So we'd be increasing by a factor of 27, or by a factor of 9, or by a factor of 3. It all depends what dimension we're talking about. And so I went over that kind of briefly in the notes. Well, not briefly, but I went over it. 63, how will the surface area, well, let's read it from the get-go. Suppose you build an architectural model of a new concert hall using a scale factor of 30. So it's a 1 to 30 scale factor is what this thing is saying, right? What will the surface area of the actual concert hall compare to the surface area of the scale model? So how much larger will it be? Yeah, how much larger will the actual concert hall be?
$30 times larger.
So if we're talking about like the height of the building, that would be correct, right? We have 1 here and we have like 30 here. But now we're talking about surface area. So surface area isn't going to be in what dimension?
Second.
Yeah, so we have to take 30 and we have to do what here?
Square.
Squared. Okay. So 30 squared is going to be what? I think it's 900, right? Am I doing that right in my head? 900 times as large, surface area wise. If we did volume, we'd have to do what? 30 cubed? And so I think this is also going back to that example I did in the notes with like the if I double my height, how much has my like waist grown? How much would my clothing grow, right? How much more clothing would I need? How much more would I weigh was the other thing, I think, something like that. Oh, look, I just said that. I got in here. Suppose you magically quadrupled in size. That is, your height, width, and depth increased by a factor of 4. So in the single dimension, we're increasing by a factor of 4. But if we talk about weight, and I'll give you a hint, your weight's going to be determined upon your volume or your mass, right? What factor is your weight going to increase by?
4 to the third.
And that's because it is a volume measurement, right? We're talking about volume, we're talking about the third dimension. And so this is 4 to the third is what? 64? It'll be 64 times heavier. I think this might, maybe I might be speaking on my way, but I think this also like helps to like describe why like certain weight gains like are more noticeable too, right? Well, that's more proportional thing. So consider a person named Sam who is okay, who is 20% taller than you, but proportioned exactly the same way. What size is your waist? I don't know. What size is Sam's waist then?
It's a stupid fucking question.
Personal, ain't it?
So this would be the circumference and 2D.
This is just your waist. They're just measuring the length around your waist. What would we have to do? Yeah, I think they're trying to like make things a little complicated on this one, to be honest, because it's like 20% larger, and now you're trying to think about dimensions in that at the same time. But if I want it 20% taller, your waist is going to be 20% longer as well. It's still a single dimension. If we want to figure out 20%, and I kind of said it, we want to figure out 20% of what, 60? That should give me 12, and so if I add that to 60, 72 then. Another way you can just do, it's going to be 120% of 60. So we haven't gotten to like percentages yet. So that's what's kind of annoying about this. They kind of throw some problems out at you that they probably really shouldn't quite yet. Okay, I wouldn't focus. Probably don't focus too much if I'm like, rah, right? Probably not going to be the thing I ask you on the quiz or test. Squirrels and humans are both mammals that stay warm. Oh, the squirrel, I don't know. I guess we got some squirrel boys somewhere up in here determining the problems that we're doing here. But squirrels and humans are both mammals that stay warm through their metabolism that takes place in the body volume. So mammals must constantly generate internal heat to replace the heat they lose through the surface area of their skin. So 75 says, in general terms, how does the surface area to volume ratio of squirrels compare to that of human beings? So a squirrel, as compared to a human being, what would you say? Do they have more surface area to volume or less surface area to volume?
More.
Is it more? Why would you say that, I guess?
Because isn't it when you're scaling down, if that decreases, then your surface area increases?
If you're scaling down, that's a good question. I thought I knew this one, and I'm not so sure. It's like I thought squirrels would have smaller surface area to volume. I could be wrong. I'm about to look. Let me see. I answered odd. 10A. I'm not that impressed by this question, if I'm being honest. I think they spend a little too much time with these. But scrolls
Yeah.
have a higher surface area to volume ratio, is what it says. So I think what you said about scaling down is correct.
So yeah, that's what I thought it was higher. The reason I thought it was higher because it's I guess the amount of okay. So first of all, I was thinking of height, and then I was thinking of the area as far as the surface. And so I was kind of like, okay, so we have they have a higher one than we do.
So I think the next one like kind of answers it though too, because I think we know like squirrels have a higher, like I hope you know this, like squirrels and a lot of smaller animals have a higher metabolic rate, right?
Yes.
And so like this next one kind of brings it into context, I guess. So which animal must maintain a higher rate of metabolism to replace the heat lost through its skin? Squirrels or humans?
Squirrels.
It's like the little shaky chihuahua, right? I can bring my she's laying down, never mind. I'm not gonna wake her up. But they're always little shaky things because they have a high metabolism rate, right? Which animal would expect to eat more food in proportion to its body? The squirrel, to keep up its metabolism. So it's got a high surface area to volume, so it's just like bleeding out all that heat, right? Is what they're trying to get at. Me personally, if I were to tell you like what problems to focus on, it wouldn't be this one or this one, right? It would be probably the other ones and a lot more of the geometry-based stuff where you have to draw a picture. I like this stuff. But you should know your dimension analysis too, right? Just not with like annoying fractions or percentages. This shows the layout of a backyard that is usually seeded with grass, except the patio and flower garden. What is the area of the region to be seeded with grass?
So we'll have to find the whole surface area and then subtract those non-seeded areas.
Yeah, exactly. So we're going to find this whole thing, which is what? I believe 20 by 10. So that's the area of the big thing. And we're going to have to subtract that from what? The area of the two other things? So how do I find the area of this thing?
Can we just do like half pi r squared?
Yeah, so you want to do pi r squared? You want to do half of this. So if you want to just divide it by 2, you want to do by half, something that you're going to end up dividing that by 2, right? Or you can just do the pi r squared and then figure out divide by 2 afterwards. My r here is going to be what?
5.
Yeah, so 5 squared, I think this should give me 25 pi over 2. So I'm plugging in 5 into my r. That's my radius. And this one should be probably one of the easier ones. What's the area of this thing?
16 meters squared.
Yeah, that's it. And so overall, what I'm doing is I'm taking that whole big thing, which is that 200, have to subtract whatever the heck 25 pi over 2 is going to be. And I have to subtract 200 minus what? 25 pi over 2 minus 16. Around 4.72. area here, we're still in meter squared. Okay, we're at 85. Did I take that too quick? You know, like saw some people staring at the screen.
So is this 25 times 3.14 divided by 2?
Oh, yeah.
Okay.
So you may be getting like a little bit off, but it should be pretty close, right? If you're not using, I'm using the pi on my calculator, so it might be like a little different, but it should be within the same ballpark.
How'd you get A3?
83, is that what you said?
No, A3 equals 16 meters squared.
4 times 4.
Okay, I see. Thank you.
83 is
Okay.
okay. Can you go back to the Jesus?
Which one?
Hey, can you go back to the Jesus? Why is my thing doing this? I'm trying to get your paper on my screen here. Yeah, okay. Jeez.
So
Can you pull the paper down, sir? I can't see it. Oh my. Okay, there it is.
we gotta like
83 equals. Okay, so the 16 is
4 by 4. I've already
4 by 4. Okay, I got it. All right.
Yeah, we gotta make better time. 85 is the human lung. I'm gonna go through the first one on this one. I don't like this problem, to be honest. It's too many big numbers, too early in the course. What is the total surface area of air sacs? So this one is the human lung has approximately 300 million nearly spherical air sacs, alveoli. Sounds like a pasta of some sort, but each with a diameter of about 1/3 millimeter. The key feature of their sacs is that their surface area because their surface gas is exchanged between the bloodstream and air. So what is the total surface area of the sacs? What is the total volume of the air sacs? So this, if I'm giving it to you, I'm going to give you those formulas. There's no way I'm not going to give you a sphere and not give you those formulas. So they want to know what the surface area. 4 pi r squared. So if we do 4 pi, and our r squared here is it's a diameter of 1/3, so we're gonna have to half 1/3. I don't want to spend a lot of time on that, but if we half 1/3, it's going to be 1/6.
So it's 12.5.
And we
So
have
it's
to
12.56 times 1/6. Or okay, so wait. 1/6. And so I have to do that first before I do the pi equation, right? I got 12.56 for 4 times pi. And so I believe that 1/6 it goes times 1/6.
so you got to multiply it by 1/6 twice. Did I get?
Okay.
Is that what they're getting? I think they're getting. Are they multiplying it by? What are they doing in the back? How are they getting a stupid number? They're getting 1.05 times 10 to the 8. Okay, that's annoying. I know what they're doing. They're doing by the 300 million is what they're doing. They get the surface area. This is kind of annoying, and this is why I don't really like this problem. But we're gonna get something like 0.349, somewhere around there. And if we multiply by 300 with 1, 2, 3, 4, 5, 6, it's given them this crazy number. So this is for 1 sac. If we want to know for 300 million sacs, it's going to be this number right here. And they like round it. They put it in like scientific notation in the back of the book. In the back of the book, the answer should look something like I think the back of the book looks like 1.05 times 10 to the 8th. And we haven't even done scientific notation yet, so I guess we're just jumping right to it on this chapter. Unit analysis does come along later. I think it's chapter 2 or chapter 3 is where we start doing unit analysis. And so these things will hopefully come into more context.
0.3. Okay, so I got 0.2. I got 0.333. I don't know what I did. Okay,
So we're doing for the volume, we're doing 4/3
0.349. 3. Jesus.
or pi r cubed. So we're doing the same r this time we're cubing it. So 4/3 pi, and we're doing r cubed, which is 1/6 cubed.
So that's 4/3 times 3.14, and then you go 1/6 times 3. Is that correct?
I don't know what you're doing over there.
Is it 1/6 times 3, and then you do 4/3 times 3.14? Is that correct?
Yeah, you do 4/3 times 3.14, and then you multiply it by 1/6 3 times.
Multiply it. Okay.
So 1/6 to the third is going to be 1/6 times 1/6 times 1/6. Right?
There you go.
So with this, I'm getting something like 193, something in there. And then if I wanted to figure out for what, 300 million, 300, 1, 2, 3, 4, 5, 6. I'm getting something like 5.881. And if I convert this to scientific, it'd be 5.8 times 10 to the 6. And this one is going to be a cube. So these are not simple sort of things. But if I give you a formula, you should be able to understand like what this formula means. You should be able to plug it in. I wouldn't do the times 300 million thing that they're doing, right? But the rest of it, I think, is okay. In part B, they're trying to get at, okay, if this was all a single sphere, would it have more or less surface area to volume? And you could probably guess. I think you said something, but you're on mute.
Oh, less.
Yeah, it would have less, right? And so this is just like trying to get at, the body's kind of, well, I don't want to say it's intelligent. It's the body's designed to work, right? Basically. So if we had a bigger sphere, it wouldn't have as much volume or surface area to volume. If it was, so based on it, comment on the design of the human lung. It's designed okay. It works. I don't.
Agreed.
Yeah, I mean, it's like I feel like they're almost trying to make an intelligent design argument there, and it's just like, no. It's designed well enough to work. That's what basically any biologist will tell you, right? Now we want to talk about the channel. I feel like this is a lot better than all the rest of them. So the channel is this English Channel tunnel. It runs a distance of 50.45 kilometers. It consists of 3 individual tunnels, 4 meters in length, or a radius of 4 meters, sorry. So we got a length, we got a tunnel. They ask how much earth, I guess they give it to you, how much volume would have to be removed for this tunnel? So they give it here, they are half cylinders, right? Ooh, let's break that calculator. I got my little tunnel here. I know what the radius of this thing is 4.
Yes.
Radius equals 4. 50.45 kilometers. So we hadn't talked about this, but I think we want to move things to meters in this thing. So if we have 50.45 kilometers, we want to move it 3 decimal places. 50, 450. That's meters. So we want to know the volume of a, what sort of thing is this? A cylinder? A right circular cylinder, I believe. Was that last shape in that chart? So how do we do this? It was pi r squared h. Pi r squared h, I believe, is the circular cylinder.
So in this case, our height is 50,450 meters.
Yep, that's it. So it's just like a cylinder, but maybe like laid on its side from what it might have been in the picture. I don't remember. But yeah, we have v equals pi r squared h. So this is pi. My r is going to be 4 squared. My h is going to be the 50,450. Hopefully I didn't break it. Okay, so this is 4 squared times 50,450 times pi. I'm getting something incredible like 253,5893.59, something like that. And this I'm talking about meters cubed. I'm talking about volume. And so if I do this, is this what they're asking for? I guess is my question.
So when you did the first equation, did you get 807,200?
I don't know what you're talking about.
The 4, 2, is that 4?
This is 4 squared, should be 16.
Okay.
And so we had to multiply it by 5. Yeah, I can't go over like doing operations on these things. Like if you need help with that, I can do that after class. But like I really don't have time during class to do these operations.
Fine.
Okay. So if this is my volume, there's one sort of other thing I really need to do to this, right? Is what I was getting at. What should I do? This would be the whole cylinder.
You need to half it now.
I need to divide this by 2. So I need to half it. So 1/2 would give me I'm getting something like 126,7946. So I think it's a million. And this is meters cubed.
Does that answer the problem though? Because it says it consists of 3 individual tunnels. And if they're each shaped like a half cylinder, then wouldn't you need to either multiply it by 3 after you divided it by half, or could you multiply the initial volume that we got by 1.5?
I think the entire thing is 50.4. I might be reading this wrong, to be honest. I haven't checked with the back of the book to see whether our solution matches what they're saying. But I think what they're saying is it's like, what do they say? Three individual sections. They're
Right.
adjacent tunnels, and it looks like, I think they're saying the 3 of them run 50.45 kilometers total.
Okay.
So I think they're like connected, right? So it's got 3 sections in there, but I think all in all, I could be wrong in how I'm interpreting it again, but like I think what it's saying is that it's just sectioned into 3 sections. I think that's kind of, I think they're giving you extraneous information, but I could be wrong.
Okay.
It's not very clear in the way it's written, to be honest. And like,
Yeah, I've found that with a lot of the questions in this book.
yeah, I'm gonna be a little more clear if I write a question of like what I'm expecting, hopefully.
Okay.
.8 times 10 to the 6. Yeah, I think they're doing this times 3. I think they're doing that times 3 is what it looks like the book is doing.
So
this
then,
would give you one
so then to
section.
cut out this step, what we could have done, sorry, you don't see where I'm pointing. So to cut out the step where you half it and then times it by 3, you could have multiplied the 25, 35, 893 number by 1.5, right?
Yeah, that's the same thing.
Okay, cool. Thank you.
And I think that's the last problem on there that we got to do. Yeah, that's it. So we got to get convene. So a little bit about this. We got these angle conversions. So this is 32 degrees right off the top. I can pick out the whole degree that I'm talking about. Now I have a half degree. And I talked a little bit about this, but my conversion factor between degrees, minutes, and seconds is. And so what am I doing to find out how many minutes are here?
Divided by 60.
No, not divide. It's going to be the other way. If we multiply by 60, we'll get there. So I know this is before we start doing unit analysis. And so like I said, we're just going to kind of get like a shorthand to getting this. But we have 0.5. We need to know there are 60 minutes in a degree. There are 60 seconds in a minute. We multiply this by 60. This is going to give us 30 minutes. You had the 60 down. That's half of it. That's a good portion of it. Knowing that number, right? Same thing here. We're going up there. I have 149 degrees. And so I take that 0.83 and I multiply that by 60. That's going to give me what? 49.8. I can take my whole number off of there. 49.
Is times 60 or divided?
It should be multiplying by 60. So big to small, we're going from a big degree to a small minute. Big to small, multiply all, small to big, divide the pig. You know one? And so that's 49. When I take the 49, I just take the 0.8, multiply by 60. So this way, we're going to multiply. The other way, how do I do this? I'm doing 8 plus 59, and I have to do what with that 59?
$60.
Yeah, got to divide by 60. And now this one might be the trickier one, plus 10. And I do have to divide this by 60. But I also have to divide it by 60 again. So there's a few ways you can do that. One way is that you're just multiplying by 60 on the bottom, right? Another way is multiplying 60 by 60. 36,000. And so at this point, you're probably going to want a calculator of some sort to get this decimal. Plus 59 over 60 plus 10 over 3,600. What's round to? It doesn't say what's round to. I think we're going to go 4 decimal places. Okay. So these, I think you should be able to do these, hopefully. It's multiplying by 60, dividing by 60. Find the latitude and longitude of the location on Earth precisely opposite to Toronto. So this is that antipodal thing. This one is the 44 north. If I want to swap it and drill a hole through the Earth, I'm going 44 degrees, and what am I going to do to that thing?
That's on south.
Yeah, make it south. The 79, that's the one that's a little bit tricky, right? Do I remember how to do that? So I gotta take 180, and I have to figure out what adds up to 180 with 79.
One.
So this is 101. Started out west, now we're going to be east. Okay. And so for the next one says, which is farther from the North Pole? Buenos Aires, Argentina, which is, I put it right here. This is its coordinates. Or Cape Town, South Africa, which is right here. I put its coordinates. So I'll give you a hint. I wrote this number. That one really doesn't matter too much, right? What we're really looking at is that right there. So it says, which one is farthest from the North Pole? Which one is that going to be? Do you remember how these things are going? Remember the equator's like 0. I think here's like 30 south. Here's like 30 north. And I think at the North Pole it's like 90, I believe. Maybe I have that off. Which one's going to be further from? I'm sorry, which one?
Buenos Aires?
Yeah, it'd be the Buenos Aires. That's the 34 degrees, right? It's just a little bit further. It's a further south. It's going to be further away from the North Pole. When further? Further south. That's probably a good enough explanation, right? Okay, so Buffalo, New York is nearly at the same longitude as Miami, Florida, but Buffalo's latitude is 43 and Miami's is 26. About how far away is Buffalo from Miami? And I don't expect you to know this conversion factor, so if I were to give you something like this, it's 69.4 miles for every degree. So what's the first thing we want to do? If we know like this conversion factor is this many miles per degree, and we know this is what, 43 degrees north, this is 26 degrees north, what's the first thing I'm going to want to do with those numbers?
Subtract Miami from Buffalo.
Yes, I'm subtracting 43 from 26 to find the difference in degrees. Ooh, excuse me. 43 minus 26 is going to give me 17. So I know I got 17 degrees difference. So how do I figure out how far apart they are? I take 17, and what am I doing with it?
Multiply by 69.4.
That's exactly what I do. 17 by 69.4 is going to be 1179.8. And I'm talking about now miles. 39. Okay. The sun has an angular diameter of about 0.5 degrees viewed from Earth and a distance from Earth of about 150 million kilometers. What is its true diameter? Okay, so this is the formula they give us in the book. Angular size equals physical size times 360 over 2 pi distance. And I talked a little bit about this, about like writing those equivalent like sort of fractions with like the circle versus the size of the object. Okay. Do they give us angular size in this thing?
No.
What? What does it say?
You give us the size.
This is what they're talking about right here. So the angular size should be the 0.5 degrees, I believe. And they're talking about the sun. It has that angular diameter as viewed from Earth. And they want to know what is the true diameter. So what are they asking for? They want to know the true diameter of the sun. This is like what it looks like relative to us. This would be the actual size of the sun, right? And 360 is just 360 degrees. There's not a lot I can do there. 2 pi, and I'm going to multiply by the distance. And so what is my distance here?
150 million kilometers.
150 million kilometers. So there's a few ways you could probably actually do this. If I do 150, I have to take note that I'm in millions of kilometers. I guess I could do the 150 million. And then take note I'm in kilometers. That's another way you can do it. You have to like take note that you're going to be in millions of kilometers somehow. Okay. So I talked about this in the notes, but this is a thing multiplied by a thing, by a fraction. If I want to solve for this, the easiest sort of way to do it, and we haven't done a whole lot, but the easiest way to do it is to multiply by this guy's reciprocal. So if you reciprocate this thing, 2 pi, that's 150 million over 360. This should give you the physical size of it. So I took this thing, I flipped it, and I multiplied it to both sides. So if I multiply this by its reciprocal, it's just going to give me a big fancy 1 on this side, which is how I'm getting the physical size. If I do it on this side, I got to throw this into my calculator. I do 2 pi, I do 150, 1, 2, 3, 4, 5, 6, and I divide that by 360, and I multiply that by 0.5 or a half. I'm going to size is something like 138,996. What, kilometers?
Is that 1,308,000?
That is. Which is a little short. It's 1.39 million kilometers is what they're saying. But that's probably a rounding error. They're also approximating their things of how far the sun is as well. That's not a constant distance. So it probably comes from that, but that's pretty close. So we can use angular size to predict physical size if we know the distance, right? That is something that they do. 345, so now we got 43, 45. It's got a grade, so now we're talking about these things, slope, pitch, and grade. So now we're talking about fractions and comparing our fractions, seeing which one's larger. Determine which one is steeper. So which one is steeper is synonymous with saying which one is the larger fraction. So if we have a 3% grade or a railroad track with a slope of 1/25. So there's a few different ways you can do this. 3% would be 3/100, just knowing the definitions of percentage. Or 1/25. So which one of those is larger? What? I heard something. I didn't hear what.
That would be 4/100.
Oh yes, you could do 4/100 over here. So you can convert this to 4/100, and then right away, I hope it's obvious. 4/100 is going to be larger than 3/100. I think the other way, the way I learned it in like elementary, was like what? You gotta write the number on top, but as long as you do that, you know 75 is larger than. Said it backwards. You know 100 is larger than 75. So we compare that fraction. We want to compare this fraction. Slope of a roof is 8 and 12. Oh, now they're asking us a question. It is a little different. So what is the slope of the roof with 8 and 12 pitch? So if the pitch is 8 and 12, we can write that as what? The fraction 8 divided by 12. And if I asked you what the slope of a line was and you could tell me 8/12, I would take at least half a point off. And I would tell you reduce that thing. So if we reduce this thing, what does it reduce to?
1/3.
2/3.
Yeah, should be 2/3. That's what I heard.
2/3, yeah.
Divide by 4, top and bottom. Should get you to 2/3. So what is the slope of the roof? 2/3. How much does the roof rise in 15 horizontal feet?
Hmm. 15.
I'll
So
do
that times or
That's rise and that's run. There's a few ways to do this. What did I say, 15? Is that what they gave us?
yeah.
They gave us a 15 run and they want to know what's the correlating rise, right? So this is a similar sort of fraction thing that we can do. If you want to make this x, you can make that x and make it super complicated. But I think going from 3 to 15, we got to do what? Multiply by 5? I think this one's probably easier than that. And so what would my rise be?
$10
Yeah, it'd be 10 feet. There's a few ways we can solve this again. So 3x equals 30 is one way you could do it. You could get x equals 10. You could recognize that you're multiplying by 5 here to get there. So there's more than one way to get your solution in some of these. You got to know one correct way at least, though. Okay. We're on 45. I'm about halfway done with this thing. One would be next. Ooh, one of these problems. 51 says they want to know. So they want to know the shortest possible walking distance, and then they want to know like the straight line distance between the two. And so they say from the bus stop to the library. So we're going from the bus stop to the library.
1 8. 4.
And there's a few ways you can do it, but I'm just going to take the straight path, I think. Probably the easiest.
So there's 1.
It should be the same any route you take as long as it's the shortest path. And there's a few ways you can do the shortest path.
So it goes.
So how much is the first part going to be?
Is it 1/8 times 6?
3, 6, yeah. We got 1/8, we got 6 times, and we also have what?
Then 1/5
Yeah.
times.
It is just once. We're just going up once. Yeah, that's it. If I want to do multiply by 1, I guess I can multiply by 1. It's not going to do anything. So I do 6/8 plus a fifth.
So that goes to 3/4 times 3/4 plus 1/5.
I think it's giving me like 19/20 or something. So if you want to, you should really like be finding common denominators to add fractions and stuff like that. But I think if I just say 0.95, that's probably more descriptive than like giving you 19 point something, right? And so
0.95. Yep.
yeah, this might be one of those things that like you have to maybe look at the context of the problem.
Yes, because it said 1920.
Yeah, if I told someone 19/20 miles, you'd be like, get the hell out of here, right? Give me 0.95 miles. That means a lot more to me, right?
Okay.
So that's A.
Okay.
And just to recap, I think if we go this way, we're going 6/8. If we go this way, we're going 1/5. So if we want to know the straight line between the two, what are we going to have to use? There's something we're going to have to use to figure that out.
Good old Pythagorean theorem.
Yeah, that math code that exists. Right? A squared plus B squared. Did I talk about the irrational numbers with the Pythagoreans yet? There's a lot of like math history, and there's a lot of history in general. It's just like we don't really know whether it actually happened. It's like it's kind of fabled. It might have happened. It may not have. But previous to like Pythagoras and everything, they didn't really talk about irrational numbers. There's like a myth about a guy going out on a boat with Pythagoras, and he suggested that irrational numbers existed, and he didn't wind up coming back on that boat. So it's really kind of weird that people get really emotional about the sorts of things that we take for granted as basic sort of logic. But if I want to figure out what this thing is, what's my A, what's my B, what's my C, I guess is my question.
Your A is 6/8, your B is 1/5, and your C is our mystery line.
Yeah, an important thing is to put this as your C, right? So 6/8 squared plus 1/5 squared should be C squared. So if I do 6/8 squared plus 1/5 squared, I'm getting something like 0.6025. Hey, if I did that as fractions, it's 241/400. That's not pretty. Let's just keep it that. So this is C squared. What do I want to do to figure out what C is?
Square root it?
Square root it. So somehow you're going to have to figure out on some sort of technology how to square root this thing. If you want to square root this thing by hand, I don't know, bless your heart, but I'm not going to do that. This should be in miles. Did I say that? Yeah, this is miles as well. And I want to step back. I want to look at this answer, and I want to look at that answer. And do those make sense with respect to each other?
Yes.
Yes. This one should be longer than this one. This should be the straight line. This should be the shortest path. And you can even look at these. It should be shorter than this one, right? But it should be a little bit longer than both of these, right? This is like 3/4 or 0.75. So yeah, it falls right in where we kind of expect it maybe to fall in. Ah, this one's a little bit interesting. How many different paths between the bus stop and the library have the shortest possible walking distance? That's interesting. So this is one of the shortest possible walking distances. Do you see what they're saying maybe? So if we go, this is the way I kind of thought about it too. I could go this way. That's another. That'd be 2. I could go this way. This would be what, 3. I could go this way and go up this road. This would be 4, 5, 6 is what I'm determining. Although, oh wait. I can go up here and go this way too. 7. 1, 2, 3, 4, 5, 6. I believe there should be 7 different paths. So I think that's one that's going to make you think for a minute. I don't know what to say about that. It made me think for just a second. It's not as straightforward, like here's the formula for it, sort of thing. Does everyone see those separate paths that I'm talking about, hopefully? I know there's only so many colors I can draw over themselves before they start getting blurry. Okay. 56, the shortest possible path. I think that's fair enough. This going from acres to feet squared and all that good stuff. '57 says the stream frontage is 200 feet in length and the property line is 800 feet in length. Are they doing it? I think they're doing it the same way. Oh man, I didn't look at the figure. This is what I get. Oh no, that's in the next thing, right? Figure 3 point. Is it 10.33? God, what do those figures look like? I thought I had all my figures on here. Let me double check, make sure. Part 5, part 4. This is 57. Okay, so they're saying 250 length. Stream frontage is this thing up here. We're doing a right triangle. So the stream frontage is 200 feet. The property line is this thing right here, which is 800 feet. So this is the sort of picture that they're trying to give you. So you might figure out where we have a right triangle. Guess what formula we're going to use again? Well, we got to figure out area of this thing, right? Is what they're asking. So if we want area is a half a base height. Guess what we got to do?
Height.
Yeah, we got to figure out what the heck this thing is over here, right? This is like our base, this is like our height, or I guess you could say vice versa. We got to figure out what that missing dimension is in order to find our area. That is our goal. So in order to find out this dimension, what sort of useful property am I going to use? I'm going to use that guy again, but it's going to look a little bit different this time.
So we'll solve for A.
So you're solving for A, is that what you said?
Asking, but yes.
Yeah, okay, yeah. So we would put, what, A squared, so we want to solve for A. So I'm already filling things out. What should I put in for my B? Let's pretend we're going to do that. You have some options of either 800 or 200. You're going to choose the 200. Why did I choose the 200? And the easier way is probably to answer this, right? This is my what?
Hypotenuse.
My hypotenuse. So I have to put that in as my C. Plus 1, 2, 1, 2. If I want to solve for A squared, what do I have to do?
So is that 400? I mean, is that 40,000?
Yeah.
Yeah, okay, that's what I thought. Yeah. All right.
Can you subtract 640,000 minus 40,000?
Yep, I'm subtracting 40,000 from both sides, basically. That's it. And if I do that, this is 600,000. So that subtracted kind of nicely. And what do I have to get A?
Square root?
Yep. And so this is giving me what, 4 point, I don't know, 597. Probably pretty good. Do 3 decimal places. So this is 774.597. Have I answered anything they asked me? Not quite. So what are they asking? I want to find the area of this plot of land.
Yeah, so A is
So what is the area of this?
97. So now we got to do
Half the base times height.
So it's 779.597 times. I mean times 2. I mean
Times 200, and then we're going to divide that by 2.
okay.
I think this is times 100, ain't it? 2 decimal 77459.7, I think is somewhere around there. And this was when we had feet by feet area. This was feet. This should be feet square. And this is one of those things it's still annoying me. We haven't done unit analysis yet since 5.9. What is feet squared? And then what feet squared up there, and then what acres on top to get rid of it. So this is just to kind of tell you whether you're multiplying or dividing. But if we want to get to acres, we're going to have to divide by that number. And so I have this number 77459.7, and I got to divide that by 560. It's giving me about like 1.78 acres, somewhere in that ballpark. And again, if you're like just off by a few hairs, if you can help me like 1.5 acres or 1.8 acres, probably pretty close, right? Like if it's a rounding error, I'm probably not going to be too picky unless you're like way off. Like you got to be close, right? But I'm not trying to nip you for some rounding errors. But you can't be way off. You can't be telling me like 3 or 4 acres or something crazy, right? Okay, so where are we at? Go back to these notes. We did 57. Now we're doing similar triangles, 65. We want to find X, we want to find Y. Oh, this was too easy. So what are the ratios I can write on this thing? What are some equivalent ratios?
I think that's 66 on 65.
Am I going back, doing that same thing again?
Yes.
That's 65, huh? So what's some equivalent ratios I can write here? What to what equals what to what equals what to what?
Is it a squared plus b squared equals c squared?
You could do that with this. You could figure out that one with this. This one might be a little bit harder to figure out, right? Because you'd have x squared plus y squared equals 5 squared. So this is similar triangles.
Do we just half it?
Yeah, that's
Would
one.
it be half of the a squared?
Yeah, I would really like to do this like with ratios though. This one is easy because it's having it. But this would be what? 10 is to 5 as 6 is to
Y.
y. And if I really wanted to do this, you could cross multiply things. I think that's the easiest way. 10y equals 5 times 6 would give you 30. That would give you the y equals 3. And I know that's probably a lot more work than you want to do on this one, but it'll help you with other ones that are more complicated, right? Y equals 3, x equals 4. But if we want to do this, 10 to 5 is still the thing, and we're going to do 8 to x. 10x equals 40. We're going to get x equals 4 out of that thing. Another way, I could go like what, 10 to 8 is equal 5 to x. So sometimes people do 2 sides at a time. That's also another way to do it. Okay. And we're getting close towards the end of class. So if you got to burn out, I guess you can go ahead and burn out. But we've got like 4 or 5 problems left. I think I'm going to go ahead and go through them. So solar access, assume that there's this solar access policy as an example 8. It looks something like this. So what they're saying is that they have a 12-foot fence that's casting a 25-foot shadow. And what your policy says is you cannot build your house any taller to cast a shadow over this fence. And so I kind of labeled everything that they give you in this problem. We have a 12-foot fence on a property line that casts a 25-foot shadow on the shortest day of the year, and the north side of the house is set back 60 feet. So we're setting back this house 60 feet. from the property line. They want us to find what is going to be the maximum height on this thing. So they're giving you this, and I like this problem kind of. You can do this with any kind of shadow casting problem, right? So
That's a quick question.
Huh?
Quick question.
Yeah.
When will all of this be due?
So this will be due Friday night.
Okay, thank you.
Yeah. So this is the thing that we want to know over here, right? We want to know how high can we make this house so that it's not going to overcast this thing. What do we know about these two things? And I hope there's like two things you can see here, right? This sort of thing happening here. There's like a 12 and 25 right triangle right here. I hope you see. And then there's this other triangle. If I look at this whole triangle, the overall, this bottom is going to be what, 60 and 25? So the entire thing is going to be 85, I believe. And this is the thing that I want to know. So what do you know about these two triangles? And it's kind of maybe they're trickily giving you this information. I don't know. Maybe it's kind of a tricky way that they give it. But we know that this is a right angle. And what do we know about this angle and this angle?
They'll be the same.
It's the same angle that we're talking about. And so if this angle is the same angle, that's the right angle, then we know that this angle also has to be the same as that angle, right? Because they're both right triangles. Adding up to 180. We know two of the angles, the third one's got to be the same, right? And so if those angles are all the same, what can we say about these triangles? They are what sort of triangles?
They're similar?
They're similar triangles. And you can do this with almost like any kind of shadow. There's that problem where like they give you the shadow of a tall building, and then they give you the height of your shadow, and then they ask you how tall is the building. You can actually get building heights by doing this and going out in the whatever time of day. As long as it's the same time of day, the sun's at the same angle, you should have like similar triangles, right? With your height and your shadow and the building and its height and its shadow. So we can do this with like a lot of things. We can find the height of tall buildings doing this. But we're going, hopefully you see it, 25, and I'm carrying that to 85. And what am I writing over here? I'm going 25 to 85, and then I'm going
12x?
12 to, I think you said it. You said it in the right order, 12 to x. Yep. So now I probably got to do something like this. 12 by 85 is going to give me 1020. 25 by x is giving me 25x. 85 by 12 gives me 1020. So I take 1020 and I'm dividing by what? 25 to get 40.8. Here I'm talking about feet. So you can build your house 40.8 feet. That's what, like at least 4 stories, I think, right? Usually your stories are a little over 10 feet, 9, 10 feet.
So how did you get the 4080? Did you divide 25 by, did you multiply 25 by 1020, or how did that work?
So this you're dividing by 25.
Okay.
Dividing by 25 there.
Okay, that's what I'm.
And this, let me go and write this just in case anybody's confused. This is coming from that 12 by 85, right? This is where I'm getting that 1020.
I have a question.
Yeah, what's up?
So I'm writing all this down and then I transfer it to a Google Doc. Do you want us, or do you want me to like draw the shapes on the Google Doc as well, or just how like to do the problem and the answers?
This is a good question. I think, and it's going to depend upon the problem. I think if I can see that you know what you're doing, I think you'll be okay with probably not drawing the pictures. But in general, like I would draw a picture if you're working through something.
Okay.
And if you're doing a test or something where I want to see the work more so, I would suggest drawing it.
Okay.
And if you have to, you can draw it on a separate paper, draw it by hand. That's fine too. I mean, that's kind of what I expected, to be honest. To do everything by hand and just do the Genius scan. Okay, so this is 69. I think we're getting close, right? 79. So suppose we have a cardboard box that must have a volume of 8 cubic feet. The cost of the cardboard is 0.15 per square foot. What's the most economical design of the box that minimizes the cost, and how much will the material for each box cost? So we talked a little bit about this optimization, but what's going to optimize this cardboard box? Okay. So the thing that's going to optimize this is if this is a cube. And so if this is a cube, the volume of our cube is equal to a side being cubed. So if we want to figure out what the side is going to be, we have to take a cube root of 8. So this is maybe a little bit ahead of this class, and so I don't really like putting this section right here. But here we go. A side would be 2. And if we look at what the surface area of a cube is, the surface area, you have 6 spaces. And 8 is like S squared. So if we're looking at this, I believe the most surface area we're going to get, or the most surface area we'll get, will look like 6 times 2 squared. I believe that's going to be 24. And we're talking about, what, feet squared? And so if we have 24 feet squared and we know it's 15 cents per feet squared, what we have to do is multiply the 15 cents per feet squared times the 24 feet squared. And this should give me a total of 360. $79, and we have 96. Okay, so this is the next problem, and the problem basically asks, we want to find the length of this sidewalk. And so I don't want to spend a lot of time going over this, but we basically want to sort of look at this thing. And you might notice each of these things makes a right triangle with the sidewalk. So we just have to figure out what these dimensions are going to be. So if we're looking here, this dimension here, the height of this triangle is going to be what? 40 minus 15. I'm getting that from this whole side minus this portion. So that's giving me 25 here. This side right here, from here to here, is going to give me, this is 30, this half is 15, so this part has to be 15. This whole thing is 40. If I look here, this accounts for 15, this accounts for 15. So that is 40 minus 30 will give me 10 meters there. And if I look across here, this is 30 meters going across there. So for each of these, I'm going to have to do Pythagorean theorem. So if I do 10 squared plus 30 squared, and then I take the square root of that, I'm going to end up with something like 31.62 for this little section. If I do 15 squared plus 15 squared, and I take the square root of that, I'm going to end up with something like 21.21 for this little section. And if I take 15 squared and 25 squared, and I take the square root of that, I'll end up with something like 29.15. And they want to know what the combined length of this entire sidewalk is. The entire length should be 81.98. We're talking about meters.
So, Okay, so Professor, do we okay, so I'm kind of confused on where we multiply and where we divide. I'm kind of confused.
On which one? So this one, we're adding this squared plus this squared, right?
Okay, but we already have that up there, right? 40, because that's what we know it is. So I'm just trying to, are we measuring the other triangle inside of the square? That's what we're measuring, right?
Yeah, we're trying to figure out the length of the gold sidewalk right here.
Right, okay.
So I have to look at these dimensions, right? And I have to look at, like, maybe subtract some of these dimensions from these dimensions and looking how they add up, right? And so this is like 15, this is like 10, this is another 15 will give me that 40 there, right? Was how I got that. And so I have to look at what these sorts of things. I'm making right triangles, and each one of these is a hypotenuse of one of those right triangles. So I'm just using my Pythagorean theorem to get the hypotenuse length.
Okay.
So I'm using 10 and 30 to get this one. I'm using 15 and 15 to get this one.
Okay, wait, no, sorry. So you getting 10 and 30?
Yes. If I do 10 squared plus 30 squared,
yeah,
and then I take the square root of that. This is the Pythagorean theorem.
Plus 10. And that will give you 3162 because you do the what?
You take this squared plus this squared, and then you take the square root. It's coming from a squared plus b squared equals c squared.
Okay.
Add a and b, figure out c.
Okay. And then on the 21, you go from the 15 and the 15?
Yep.
Okay.
And for the 29, we're doing the 15 and the 25 here. What was this next one? needed for the corral. Has Richard found another economic solution? Can you find another design for the corral, or is this one just a corral? Okay. A rancher must design a rectangular corral with an area of 400 square meters. She decides to make a corral that measures 10 by 40. This is an optimization problem. So she's doing 10 by 40. We're going 10 by 40, 10 by 40 to make a corral. And so if we do this, this is 40, 80, 90, 100 total. And I talked a little bit about this, but if we want to optimize something, I think usually the way that you go if you're making a square corral, make it into a, sorry, I said that wrong. If you're making a rectangular corral, the optimization would be to make it into a square corral, I believe. And if you want to do 400 square meters, I think the easiest way to go about that is to make it, what, 20 by 20 would give you the square root. You could do the square root of 400 would also be another way to do it, right? But a 20 by 20 meter square would give you 400 square meters. It would also give you 20, 40, 60, 80 meters of fence. And so if they're, I'm not sure what they're asking, to be honest, but if they're asking for you to remain it rectangular, then this is it. If they allow circular fences, then a circle would be better, I think.
So is that 20 times 20?
That gives you the 400 square meters they're looking for. We're looking for a square. We know the area of squares looks like S squared. So if we know we want the area to be 400, the side would be the square root of that, which is 20.
Which is 20.
And then there's one last one I think we got to go over. 89 and 96. 96 says it's a dark and stormy night. Through the beat of the wipers on your truck, you see the rickety old country bridge and marked below limit 40 tons. So they have this all set up with your truck, white lightning. Oh, they have, someone thinks they're a script writer, I think. Like the back of your hand, it weighs 16.3 tons. You're comparing a cylindrical still water tank that is full of water. The empty water of the tank is 100. The empty weight of the tank is 1,750 pounds. What about the water? We know that water is 0.03613. Every cubic inch of water weighs 0.03613 pounds. So you dash out of the rain what they measure to find. That's the length of your truck. That's the diameter of your truck. Back in the truck. Okay. So we want to find out how many cubic inches of water this truck can hold. If we're talking about cubic, that should be sort of a dead giveaway right away that we're going to talk about volume of this thing, hopefully. If we're talking about volume, we're talking about volume of a right circular cylinder. It's going to look like we take the area pi r squared first, and then we stretch it another dimension h. So this is the volume of a right circular cylinder. We're filling in the information to find the volume of our truck. So if we do pi, we do r squared, which is going to be 3 feet, 3 inches, which is a quarter of an inch, quarter of a foot. I think it might be easier to do 3.25 for that. It's kind of annoying. My height is going to be 22. And if I do this on my calculator, I get 3 times 3.25 squared times 22. I'm getting 730. It's a little bit over 730 cubic inches.
So that goes, Oh, am I on? Oh, okay. So does that go 3.14 times, and then you go 3.25 times 2, and then
No, this is squared. It's not times 2. You have to do 3.25
I mean-
times 3.25.
okay, I'm sorry.
Yeah, yeah.
Okay, so 3. Okay, so hold on. Jeez. Yeah. 3.25.
And this is the truck. So the other thing, if we want to figure out the weight of the water, we know, what is it, 1 inch cube of water. If we have 730 inch cubes, we know 1 inch cube of water is going to weigh 0.03613 pounds.
So what did I do wrong? I got 33.166. What did I do? Okay. So
3.14 times 3.25 times 3.25 times 22. It should give you 729.6575, somewhere around there. That's pretty close. That's 730. And so if we go 730 and we multiply that by 0.03613, I'm getting the water is going to be 26.3749 pounds. Where am I at now?
7.3. I think I did this wrong.
So the empty weight is 1750.
Oh, it's 729,657. I got it. Oh, Jesus. Okay, I got it. Jesus. Okay, so you rounded it off to 730, and then you divide this by 3.
I did not divide it by 3.
What do you do?
So I multiplied it by that 0.03613.
So you changed the 730 to a decimal?
This is
In the problem.
this is the volume of your truck.
Right.
This is the weight of the water in the truck. Per inch squared is what it says, per inch squared.
Oh, I see it. Yeah, 3.6. You're right. Okay, I got it. All right.
So it doesn't seem like we're even coming close to their 40-ton limit. Is that what it says?
Yeah. 40.
Yeah, because we have a 16.3-ton truck,
40 ton. Yeah, 40 ton truck.
and then we have a 1750 pounds of the tank, and then we have the 26 pounds of the water, is what it looks like.
Is that the 22? Oh, what?
And so there's a 40-ton limit. I don't think we're getting close to that. Ton is, oh man, I don't even know the conversion factor. I did not look that one up. What else we do? Oh man, I just told you that. There are 2,000 pounds in a ton. So this isn't even giving us 1 ton more. So we'll be way safe of that 40.